Exercise 2.3. First bit, find the complementary function of d square plus d plus 1 into y equals to x to the power of 4. To find out the complementary function, let's take the auxiliary equation, that is substitute d equals to m. So m plus 1 equals to 0 and do factorization. Here factorization is not possible, then use another formula minus b plus or minus under root b square minus 4ac divided by 2a. So minus b value is m coefficient plus or minus 1 square minus 4 into a value m square coefficient and c value constant divided by 2 into 1. So minus 1 plus or minus under root 1 square 1 minus 4, so it is minus root minus 3. Root minus 3 answer is I into root 3 divided by 2. So minus 1 by 2 plus or minus I into root 3 by 2. So here the roots are complex numbers. So for the complex numbers, complementary function is e to the power of alpha x bracket of c1 into cos beta x plus c2 into sin beta x. So here let's compare with alpha plus or minus I beta. So then e to the power of alpha value minus 1 by 2, c1 into cos beta value root 3 by 2, so c2 into sin root 3 by 2 into x is our required answer. Next question, d square minus d into y equals to 2x minus 1 into 2x minus 1 minus 3 into e to the power of x. So the auxiliary equation is m square minus m equals 0. Take the m common, m minus 1 equals to 0, m equals to 0, m minus 1 equals to 0, here m equals to 1. So the roots are real and different. Then the complementary function is c1 into e to the power of m1x plus c2 into e to the power of m2x. So c1 into e to the power of m1 value 0 and c2 into e to the power of m2 value 1. So e to the power of 0 into x is e to the power of 0, it is 1. So c1 plus c2 into e to the power of x is a required complementary function. Next question, d square minus 6d plus 9 into y equals to 2x square minus x plus 3. So the auxiliary equation is m square minus 6m plus 9 equals to 0. So do factorization, minus 3m plus 9 equals to 0. Take the m common from the first two terms, minus 3 common from the next two terms. So m minus 3 into m minus 3 equals to 0. So m minus 3 equals 0, m minus 3 equals 0. Here m equals to 3, here m equals to 3. So the roots are real and equal. Then the complementary function is c1 plus c2 into x e to the power of mx. So c1 plus c2 into x e to the power of m value 3x is our required answer. Second bit, find the particular solution, that is particular integral of the differential equation d square y by dx square plus 6 dy by dx plus 9 into y equals to 9x plus 6. So first of all, the symbolic form is d square plus 6d plus 9 into y equals to 9x plus 6. So the particular integral formula x divided by f of d. So here x divided by x means 9x plus 6. The right side function in the given equation is a x. F of d, d square plus 6d plus 9. Now split into two fractions, 9x by d square plus 6d plus 9 plus 6 divided by d square plus 6d plus 9. So here the function is algebraic function. When you have a algebraic function, the process is take the constant number common in the denominator. So 9 is a constant, then d square plus 6d by 9 plus 1. Okay, take the 9 common, then d square plus 6d by 9 plus 1, here x plus 6 divided by, here is numerator is a constant, then you can substitute 0 in the denominator place. So then here 9 cancel, and x divided by, first write the 1, next write the d square plus 6d by 9 plus 6 divided by 9. So here 3 2s are 3 3s are. Now it is equals to 1 plus, see here we have to use one formula, 1 by a to the power of m formula, a to the power of minus m. So then 1 by d square plus 6d by 9 all to the power of minus 1 into x plus 2 by 3. Now here we have to use one formula, that is 1 plus d all to the power of minus 1 equal to 1 minus d plus d square minus d cube plus dash. This is the formula. Here at the place of d we have a d square plus 6d by 9. Okay, so then it is equals to, continue the answer, 1 minus d means d square plus 6d by 9 plus d square means d square plus 6d by 9 whole square minus dash and into x plus 2 by 3. So 1 minus, here we can ignore the highest derivatives. Why? Because the function is x, d means derivative, d of x is 1, d square of x is 0, d cube of x is, we cannot find out, it is already 0. That is why we have to ignore the highest powers, highest derivatives. So that is why here only d square plus 6d by 9. Okay, because here if you taking this, definitely will get the 0 answer, because d square is highest derivative and whole square means it will become d to the power of 4. So plus 2 by 3, so it is equals to x multiplying inside x into here d square into x plus 6d into x by 9 plus 2 by 3. So it is equals to x minus d square x means second order derivative. So d square x nothing but d square by dx square dx square x. So its derivative will become 0 plus 6dx means derivative of x is, that is 1 by 9 plus 2 by 3. So x minus 6 by 9 plus 2 by 3, 2, and here 3, x minus 2 by 3 plus 2 by 3, both are cancelled. So the particular integral is only just x. Next question, d square minus 1 into y equals to x square. So the particular integral is x divided by f of d. So x means x square divided by d square minus 1. So x square divided by, here 1 minus, take the minus 1 common, so then minus d square plus 1. So it is equals to minus x square by 1 minus d square. So minus x square minus, here 1 minus d square whole power minus 1 into x square. So minus, so here the suitable formula is 1 minus d whole power minus 1 equals to 1 plus d square plus d cube plus dash. This is a 1 minus d whole power minus 1. So here at the place of d we have a d square. So continue the answer. So minus bracket of 1 plus d. D means d square. D square means d square whole square plus dash into x square. So minus 1 plus, here ignore the highest derivatives. Why? Because derivative of x square is 2x, d square x square is 2, d cube x square is 0. So that means maximum we can take d square. But here d square whole square means d to the power of 4. So that is why we can ignore these all terms, only d square will come, x square. So minus 1 x square multiplied inside d square x square. So minus x square plus d square x square means d into 2x minus x square, d into 2x is 2. So this is our required answer. Next question, d square y by dx square plus y equals to x square. So the symbolic form is d square plus 1 into y equals to x square. Now the particular integral formula is x divided by f of d. So x means x square divided by f of d, that is d square plus 1. So x square divided by 1 plus d square. Now 1 plus d square whole power minus 1 into x square. Here the suitable formula 1 plus d whole power minus 1 equals to 1 minus d plus d square minus d cube plus dash. So here at the place of d we have a d square. Now continue the answer. So 1 plus one minus d, so d means d square plus d square whole square minus dash into x square. Here we can ignore the highest derivative, so only 1 minus d square into x square. Now x square multiplied inside d square x square. So x square minus d square means we have to do derivative of x square 2 times. So d into 2x, x square minus derivative of 2x is 2. So this is our required answer. Next question, d square minus 1 into y equals to x. So the particular integral equals to x divided by f of d. So x by f of d is d square minus 1. X by, take the minus 1 common, so minus d square plus 1. So minus x by 1 minus d square. Now minus 1 minus d square whole power minus 1 into x. So here we have to apply one formula, that is 1 minus d whole power minus 1 equals to 1 plus d square plus d cube plus dash. So here at the place of d we have a d square. Now continue the answer. Minus bracket of 1 plus d. D means d square whole square plus dash into x. Minus, here we can ignore the highest derivative, so 1 plus d square into x. So minus 1 plus x multiplied inside x plus d square x. So minus x plus d square x means 2 times derivative, 1 time derivative 1 and derivative of 1 is 0. So only minus x is the answer. Next question, d square plus 31 into y equals to x. So the particular integral is x divided by f of d. So it is equals to x by d square plus 31. First we have to take the 31 common in the denominator. So then 1 plus d square by 31. So now 1 by 31, 1 plus d square by 31 whole power minus 1 into x. Here apply the 1 plus d whole power minus 1 formula, that is 1 minus d plus d square minus d cube plus dash. So it is equals to, here at the place of d, so here d equals to d square by 31 is there. So 1 by 31 bracket of 1 minus d means d square by 31 plus d square by 31 whole square minus dash into x. Here we can ignore the highest derivatives, so only 1 minus d square by 31 into x. So 1 by 31 x multiplied inside and d square by 31 into x. So 1 by 31 into x minus, here derivative 2 times derivative of x is definitely 0. So only x by 31 is the answer. Next question, d square plus d plus 3 into y equals to x plus sine 2x. So the particular integral is x divided by f of d. So here x means x plus sine 2x divided by f of d, that is d square plus d plus 3. Now split into two fractions, x by d square plus d plus 3 plus sine 2x by d square plus d plus 3. So it is equals to x by, here take the 3 common in the denominator, so 1 plus d square plus d by 3 plus, here we can substitute the d square as a minus a square, so minus a value is x coefficient, so minus 4, so minus 4 plus d plus 3, it is equals to, here 1 by 3, 1 plus d square plus d by 3 whole power minus 1 into x plus sine 2x divided by d minus 1. Now to get the d square in the denominator place, we need to multiply with d plus 1 and divide with d plus 1. So here we have to apply one formula, that is 1 plus d whole power minus 1 equals to 1 minus d plus d square minus d cube plus dash. So it is equals to 1 by 3. Here at the place of d we have a d square plus d by 3. So 1 minus d square plus d by 3 plus d square plus d by 3 whole square minus dash into x plus d plus 1 into sine 2x divided by, here a minus b into a plus b, a square minus b square. So 1 by 3, here we can ignore the highest derivative, so d square plus d by 3 into x plus, here derivative of sine 2x is, here d into sine 2x means derivative of sine 2x, that is cos 2x into 2 plus 1 into sine 2x divided by, at the place of d square we can substitute minus 4. So now x multiply inside, x minus d square x plus dx by 3 plus minus 4 minus 1 is minus 5, so 1 by 5 bracket of 2 cos 2x plus sine 2x. So it is equals to 1 by 3 bracket of x minus derivative of x, 2 times derivative of x is 0, 1 time derivative of x is 1 by 3 minus 1 by 5 into 2 cos 2x plus sine 2x. So here, so 1 by 3 bracket of, let's take the 3 LCM, so 3x minus 1 by 5 into 2 cos 2x plus sine 2x. So here 3 into 3 is 9. So this is our required answer. Fourth question, d plus 1 whole square into y equals to x. So the particular integral is x divided by f of d. So x by f of d value d plus 1 whole square. So x by d plus 1 can write as a 1 plus d whole square. So 1 plus d whole to the power of minus 2 equals to x. So here the formula is 1 plus d whole power minus 2, formula 1 minus 2d plus 3d square minus 4d cube plus dash. So then 1 minus 2d plus 3d square minus 4d cube plus dash into x. So here ignore the highest derivative, so only 2d, remaining 2 are highest derivative because the derivative of x will become 0 if you taking the 3d square minus 4d cube. Now multiply x in inside, x minus 2d into x. So x minus 2 into derivative of x is 1. So x minus 2 is our required answer. Third bit, first question, d square minus 1 into y equals to x. First we have to write the auxiliary equation, that is m square minus 1 equals 0. Then m square equals to 1, m equals to root 1, m equals to plus or minus 1. So the roots are real and different. Then the complementary function is c1 into e to the power of m1x. So take it as m1x plus c2 into e to the power of m2x. So take the m1 as a 1 and m2 as a minus 1. So c1 into e to the power of x plus c2 into e to the power of minus x. So now the particular integral is x divided by f of d. So x value, x f of d value d square minus 1. Now it is equals to x divided by, take the minus 1 common, so minus d square plus 1. So x minus x by 1 minus d square. So 1 minus d square whole power minus 1 into x. So here 1 minus d whole power minus 1 formula, that is 1 plus d square plus d cube plus dash. So here at the place of d we have a d square. So now continue the answer, minus 1 minus d square plus d square whole square dash into x. So here ignore the highest two derivatives, so only 1 plus d square into x. Now multiply x in inside, x plus d square x minus x plus d square means derivative of x 2 times. So 2 times the derivative, definitely 0. So then the particular integral is only minus x. Now write the general solution. The general solution y equals to complementary function plus particular integral. So complementary function is c1 into e to the power of x plus c2 into e to the power of minus x, and the particular integral is minus x is our required answer. Next question, d square plus d minus 6 into y equals to x. So the auxiliary equation is m square plus m minus 6 equals to 0. So m square plus 3m minus 2m minus 6 equals to 0. So take the m common from the first two terms, next to minus 2 common. Now m plus 3 is common, m minus 2 equals 0, m plus 3 equals 0, m minus 2 equals 0, m equals to minus 3, m equals to 2. Then the complementary function is c1 into e to the power of minus 3x plus c2 into e to the power of 2x. Now the particular integral is x divided by f of d. X means the given function in the right side, that is x by f of d, d square plus d minus 6. So now take the minus 6 common, so 1 minus bracket of d square plus 1, d square plus d by 6. Now minus 1 by 6, 1 minus d square plus d by 6 whole power minus 1 into x. So here apply the 1 minus d whole power minus 1 formula, that is 1 plus d square plus d cube plus dash. So here at the place of d we have a d square plus d by 6. So continue the answer, minus 1 by 6, 1 plus here d means d square plus d by 6. D square means d square plus d by 6 whole square plus dash into x. So here neglect the highest derivatives, only d square plus d by 6 into x. Now it is equals to minus 1 by 6, x multiplied inside d square plus d by 6 into x. So minus 1 by 6 x plus d square x plus dx by 6 minus 1 by 6 x plus derivative of second order derivative of x is 0 and here derivative of x is 1 by 6. So minus 1 by 6, here 6 plus 1, 6x plus 1 by 6. So the particular integral minus 1 by 36 into 6x plus 1. Now write the general solution. Complementary function plus particular integral. So c1 into e to the power of minus 3x plus c2 into e to the power of 2x minus 1 by 36 into 6x plus 1 is our required answer. Next question, d square plus d plus 2 into y equals to x. So the auxiliary equation is m square plus m plus 2 equals to 0. So factorization is not possible, then use a formula. So minus b plus or minus under root b square minus 4ac divided by 2a. So minus b value 1 plus or minus 1 square minus 4 into 1 into 2 divided by 2 into 1. So minus 1 plus or minus 1 minus 4 2s are 8, 1 minus 8 minus 7 by 2. So minus 1 by 2 plus or minus I into root 7 by 2. So the roots are complex numbers. So for the complex numbers, the complementary function is e to the power of alpha x into c1 into cos beta x plus c2 into sin beta x. Here let's compare with alpha plus or minus I beta. So then e to the power of alpha value minus 1 by 2, beta value root 7 by 2 into x, c2 into sin root 7 by 2 into x. So now the particular integral is x divided by f of d. So x by d square plus d plus 2. Here let's take the 2 common in the denominator, then 1 plus d square plus d by 2. So it is equals to 1 by 2, 1 plus d square plus d by 2 whole inverse into x. Here we have to apply 1 plus d whole power minus 1, that is 1 minus d plus d square minus d cube plus dash. So here at the place of d we have a d square plus d square plus d by 2. So it is equals to 1 by 2 bracket of 1 minus d, d means d square plus d by 2 plus d square. D square means d square plus d by 2 whole square dash into x. So here we can ignore the highest derivatives, only d square plus d by 2 into x. So now x multiply inside, x minus d square x plus dx by 2. So 1 by 2 x minus derivative of x 2 times is 0, derivative of x is 1 by 2. So 1 by 2, take the 2 LCM, 2x minus 1. So the particular integral is 1 by 4 bracket of 2x minus 1. Now the general solution is y equals to complementary function plus particular integral. So complementary function e to the power of minus x by 2 into c1 into root 7 by 2 into x plus c2 into sine root 7 by 2 into x, and the particular integral is what is that 1 by 4 bracket of 2x minus 1 is our required answer. Next question, d square y by dx square plus 2 into dy by dx plus y equals to x. So the symbolic form is d square plus 2d plus 1 into y equals to x. Now the auxiliary equation is m square plus 2m plus 1 equals to 0. So now do factorization. So the two roots are real and equal. Then the complementary function is c1 plus c2 into x e to the power of minus x. Now the particular integral x divided by f of d. X means the given function in the right side, and f of d, d square plus 2d plus 1. So it is equals to x divided by 1 plus d square plus 2d. So 1 plus d square plus 2d whole power minus 1 into x. Here 1 plus d whole power minus 1 formula, that is 1 minus d plus d square minus d cube plus dash. So here at the place of d we have a d square plus 2d. So then 1 minus d square plus 2d plus d square plus 2d whole square dash into x. So 1 minus, here ignore the highest two derivatives, into x. It is equals to x multiplying inside d square x plus 2dx. So x minus, its answer is 0 because derivative 2 times derivative of x is 0, and here 2 into 1 is 2. So then the particular integral is x minus 2. So now the general solution is complementary function plus particular integral, that is c1 plus c2 into x e to the power of minus x, plus particular integral is x minus 2 is our required answer. Next question is y double dash plus y 5y dash plus 4y equals to 3 minus 2x. So here the symbolic form is d square plus 5d plus 4 into y equals to 3 minus 2x. So here auxiliary equation is m square plus 5m plus 4 equals to 0. Do factorization, 4m plus m plus 4 equals to 0. So the roots are real and different. Then the complementary function is c1 into e to the power of minus 4x. So otherwise take the minus x first. c2 into e to the power of minus 4x. So now the particular integral is x divided by f of d. So 3 minus 2x divided by d square plus 5d plus 4. So it is equals to split into two fractions, d square plus 5d plus 4 minus 2x divided by d square plus 5d plus 4. For the constant, just substitute 0 at the place of d, and here we have to take the 4 common in the denominator, then 1 place d square plus 5d by 4. So here 2 ones are 2 twos are 3 by 4. So minus 1 by 2. Here we can write 1 plus d square plus 5d plus 4 whole inverse into x. So the suitable formula 1 plus d whole inverse equals to 1 minus d plus d square minus d cube plus dash. So it is equals to 3 by 4 minus 1 by 2. 1 minus, at the place of d we have a d square plus 5d by 4. d square plus 5d by 4 plus d square means d square plus 5d by 4 whole square dash into x. So it is equals to 3 by 4 minus 1 by 2 bracket of 1 minus, here I am going to ignore the highest two derivatives, into x. So 3 by 4 minus 1 by 2 multiply x in inside, d square x plus 5dx by 4. So 3 by 4 minus 1 by 2 bracket of x minus, so its value 0 and its value 5 by 4. So 3 by 4 minus 1 by 2, here LCM is 4, then 4x minus 5. It is equals to 3 by 4 minus 4 to the 8 bracket of 4x minus 5 is a particular integral. So now the general solution. So let us simplify this. So here 8 is the LCM, 3 to the 6, minus 4x, minus into minus plus 5. So the particular integral is 1 by 8 bracket of 6 plus 5, 11 minus 4x. Now the general solution is complementary function c1 into e to the power of minus x plus c2 into e to the power of minus 4x plus particular integral is 1 by 8 bracket of 11 minus 4x is our required answer. The next question is 2d square plus 5d plus 2 into y equals to 5 plus 2x. So the auxiliary equation is 2m square plus 5m plus 2 equals to 0. So 2m square, 5m can write as a 4m plus m plus 2 equals 0. Take the 2m common, then m plus 2 plus 1 common, m plus 2 equals to 0. Here m plus 2 common, then 2m plus 1 equals to 0. M plus 2 equals to 0. 2m plus 1 equals 0. Here m equals to minus 2. Here m equals to minus 1 by 2. So then the complementary function is c1 into e to the power of m1x. So here minus x by 2 plus c2 into e to the power of m2x. So minus 2x. Minus x by 2 plus c2 into e to the power of minus 2x. Now the particular integral is x divided by f of d. Here x means 5 plus 2x divided by 2d square plus 5d plus 2. Now split into two fractions. So here substitute d value 0. 2 into 0 square plus 5 into 0 plus 2 plus 2x divided by, let's take the 2 common. So then 1 plus d square plus 5d by 2. 5 by 2 plus, here 2 cancel, and 1 plus d square plus 5d by 2 whole inverse into x. So here apply the 1 plus d whole inverse equals to 1 minus d plus d square minus d cube plus dash. Here at the place of d we have a d square plus 5d by 2. So 5 by 2 bracket of 1 minus d. D means d square plus 5d by 2 plus d square means d square plus 5d by 2 whole square dash into x. So it is equals to 5 by 2 plus, here ignore the highest two derivatives, so only just d square plus 5d by 2 into x. Now x multiply inside, so x minus d square x plus 5dx by 2. So 5 by 2 plus x minus, here 0 because 2 times derivative of x is 0, and here 5 into 1 by 2. So it is equals to 5 by 2 plus x minus 5 by 2. Both are cancelled. So the particular integral is x. So y equals to c1 into e to the power of minus x by 2 plus c2 into e to the power of minus 2x, and the particular integral is x is our equation.